Hello there everybody, it's Alana Tucky, and I want to show you how to use your calculator to do some of these problems from Chapter 8 involving the sampling distribution of the sample mean. So here we have the notes from 8.1. You can see that we have a combined GRE score is normally distributed with a mean of 1066 and a standard deviation of 191. Suppose that n equals 15 randomly selected students take the GRE on the same day. All right, so for problem A, it says, what is the probability that a randomly selected student scores between 900 and 1200? Okay, well, that's a bit of a review question from Chapter 7, because if you're talking about a single student, then you're talking about a standard deviation of 191 and a mean of 1066. Nothing is being altered. You're not really talking about the sampling distribution. All right, so let's remind ourselves how to do that. Not that way. Hold on one sec. There we go. Okay, so I would choose normal CDF, so number 2. And then my lower bound, well, let me draw a picture for you real quick. So we're talking about being between 900 and 1200, right? Okay, so I have a picture of that right here. So let me paste this in. There it is. It's huge. All right, so here's 900 over here on the left. Here's 1200 on the right, and 1066 is in the middle. Let me shrink this down. And you can see the program I'm making this in, which is called Minitab, has already figured it out. It thinks that it's 0.5661, but we're going to prove it. Okay, so we're going to type normal CDF. Normal CDF. We're going from 900, comma, to 1200, comma, 1066, comma, 191. Oops, not 666. There we go. All right, and when we do that with the calculator, let me go back to it. So 10's negative, was it 900? It was 900. So 900, enter. 1200, enter. 1066. Oh, I did it again. Press too many sixes. There we go. 191. Go down to paste and press enter. And you can see right here, it's writing it out the way I wrote it just a second ago. That's because the old calculators, the TI-83s, have to write it this way. So 900, 1200, 1066, 191, enter. And it finds it, 0.5661, which matches up with what Minitab thought. So that's nice to know. There we go. All right, so that's, again, a little bit of a review from Chapter 7 because there's nothing different for that problem from Chapter 7. Now we're going to start talking about sample means. So once you see sample mean in the problem or X bar in the problem somewhere, then you're no longer talking about a Chapter 7 problem. You're talking about a Chapter 8 problem where you're dealing with the sampling distribution of the sample means. So when it wants us to describe the sampling distribution, what it wants is shape, center, and spread. And there they are. Now the shape is normal. Well, pretty much everything in this course is normal. We don't deal with non-parametric stuff. That's not normal stuff. That would be another statistics course. So, but we have to prove it. Now, normally we'd be a little bit worried because n is only 15, which is less than 30, and our rule of thumb is to be bigger than 30. But it's okay that n is only 15 because it tells us right here that it's normally distributed right in the problem. Once it says it's normally distributed for the population, then you're fine for the whole problem. You could have picked any size n. N equals 2, n equals 1, which is what you did up here. N equals 1 was this first part, and so on. It would still be normal. The mean is 1066 because that's your population mean, mu. And your spread, however, is going to shrink. It was 191, but that's for individual test takers, individual people. But now we're going to make it smaller. We're going to make it 191 divided by the square root of 15. And if I grab the calculator and type that, 191 divided by the square root 15, enter, you get 49.316 or so. Okay, so that's where that spread came from. So now I'm going to redo the problem that I just did before, but instead of talking about a single student, instead of a student, we're talking about a sample of 15 students having a mean. In other words, we're talking about a sample mean, an X bar. So what are the chances of that? Well, the picture actually changes. Let me get you the picture from Minitab. There it is. And you can see tons more of this graph is shaded. There's only a little bit over here on the right that's not shaded. And you can see it's 0.9963, so we're going to prove it though. even though Minitab claims it. I believe it, but let's prove it with the calculator. All right, so we go back to the calculator. We go back to normal CDF, number 2. And it's still 900, but if that wasn't there, I would type it. 900, 1200, enter, 1066, fine. Now here for sigma, you have a choice. You can either type 46 point, what was it, 316? 49.316. So you could type that, 49.316. And it'll do you okay. But you're rounding a bit when you do that. So you get 0.9963, that's fine. Or you could go, let me go back to distribution, normal CDF right here. Leave all that. But instead of typing the decimal, I can actually just type the problem. It was 191 divided by square root 15. Close my parentheses, enter. And there you go. Now, it's not different for those first 5 decimal places or 6, but you can see after that, they're a little bit off from each other. And the second one is the one that's more accurate because you use the square root there. It's not as big a deal for 8.1, but it can become a problem for you sometimes in 8.2. So there you go, 9963, just like it said. So we'll put that in our notes right here. So what we do want to tell it is that we typed this in a little bit differently. So hold on one sec. There we go. So we put in normal CDF 900, 1200, 1066, but then 191 over the square root of 15. Or if you prefer, you can put the decimal in, but make sure you keep several decimal places for that because you don't want to lose accuracy as you go. All right, so that's another normal CDF question, this time from 8.1. Now we're going to be asked to find a quartile. So let me fit that on the page one sec. There we go. Now you might remember from back in chapter 3 that when you have a quartile, the first quartile, that means that you're on the low end, right? It means that 25% is below you. So this area shaded down here is worth 25%. And we want the quartile for the sample mean. I'm just going to make that a little bigger. So we want this guy right here. What's the X bar that would knock off the lower 25%? Well, that's not a normal CDF question. You know the area. The area is 0.25. So this isn't normal CDF. This is its opposite. This is the inverse norm. So we need to do inverse norm. Okay, inverse norm. But inverse norm works a little bit differently. So let's go back to the calculator and look at that. All right, so second distribution. Inverse norm is number 3. Now it asks us only for 3 things: the area, the mean, and the standard deviation. Now the area, remember, has to be the left tail area. So when you look at your picture, which is one of the reasons you draw a picture, you can see that you were talking about the left tail area is 0.25. So you're going to enter the left tail area value, oops, there we go, of 0.25. The mean is 1066, no different. And the sigma, again, you either can type 49.316 or you could do 191 divided by the square root, so second square root of 15. Close your parentheses. And that will work as well. So either one, either use the decimals or just type it out and it will figure it out for you. Then I'll paste and press enter. And there it is, 1032.7. Okay, so let me write that up. We did 0.25, 1066, 191 over the square root of 15. And that came to, what was it again? 1032.7. Okay, so if I can bring that back. Which, let's face it, you can't really score that on this is an exam. You can't get 0.7 on this exam, so it's about that, 1033 when you round it. All right, that's how to use the calculator to help yourself answer problems for Section 8.1. I'll see you back here for Section 8.2.